Okay, good morning. I'm Jesse Dikun with Wm.T.Spaeder Company. We're here in Polk, Pennsylvania at the Polk State Hospital at their new membrane water filtration plant. Today we're going to go through the process and how it works, and we're going to touch on some of the things that we did here to get this project to completion. So this facility is going to run off of two different sources of water. One source being a natural spring. It's fed by gravity to the building. Then we have our pump skid here that's going to pick the water up and push it through the system. The other source is going to be creek water, which comes through this line here, and they mix here. The creek water is fed from the bottom of the hill, which is roughly 120 to 150 feet difference in elevation. So we will be installing a skid very similar to this one down at the bottom of the hill to push that water up the hill. So once the water comes through and it's mixed in this part of the system, it goes through the strainers to get most of the big heavy solids out of the water. Then it's pushed up through into these tanks here, which these tanks are called flocculation tanks. They have a couple chemicals that are introduced here through these chemical injection quills. There's two on each side. One's going to be a coagulant and the other one is a hydroxide, just to settle the heavies out of the water. And there's also up above, there's also mixers on these tanks to help that process along. So this is a fairly straightforward process. After the water is into these tanks, the flocculation tanks, the system is pretty much gravity fed from there to the end. So once the water's in the flocculation tanks, it fills from the bottom to the top. The mixers mix the chemicals that are introduced into the water before it goes into the tanks to settle the heavies out. Once that water comes up, then it transfers over to the plate settlers, which are these vessels here, which further settle the heavies and things in the water that shouldn't be there. Then it goes to the equalizer tank, which is at the head of the whole system, where the water from both sides combine, and then that in turn feeds these membrane filtration units. So it's all gravity to these units. Now each one of these filtration units has its own pump, so it can take the water that it needs from the line and filter it through as it needs. Now there's 3 units here, so I believe only 2 are going to run at a time, so they all backwash themselves, and that would be this system over here with these chemical injection pumps and hot water tanks. When these go into backwash, it stops drawing water from the system and draws water from this system to backwash itself out. Once that process is complete, it dumps that water to drain after it flushes itself, and then it can take water from the system again to filter. Once the water's filtered, it all comes together in a central header here, which is then pushed out and up the hill to the reservoir where it's stored to be ready to use for the state hospital. This facility is being built just to update the property. Their old water plant, which is at the bottom of the hill down there, is over 100 years old, and it didn't quite meet the requirements of the DEP anymore. So that's why this is here, to get everything up to date and up to spec and make sure they got good, clean drinking water. So on the mechanical side of things, basically we did pretty much everything. We installed the air compressors, we did all the air piping, we set the vessels themselves, we did all of the ductile iron piping. We set the filtration units, which were supplied by Memcor, Revaqua, or DuPont, and we did all of the finished water piping and chemical injection piping and all of that. Thank you for joining us on our walkthrough. This is a small facility, obviously. A lot of these plants are very different. This is designed to supply a state hospital, so that's one reason why it's on the small side. So yeah, thank you for joining us today, and don't forget to like and subscribe.